Hi students, in this video we'll be seeing designing FSM, right? How to design a finite state machine. You all know there are three types of finite state machine: DFSM, NFSM and epsilon NFSM. Right? So DFSM is deterministic finite state machines. NFSM is non-deterministic finite state machines, and the third type is non-deterministic finite state machines with epsilon transitions. Right? So we'll be seeing the first type, designing DFA or DFSM. DFA or DFSM. DFA stands for deterministic finite automata, or I can say DFA as DFSM, deterministic finite state machines. Right? So I can construct a DFA for various problems like pattern recognition problem, divisible by k problem and mod k problem. Right? So I can construct a DFA or DFSM for pattern recognition problems, or divisible by k problem, or mod k problems. So in this video we'll be studying about the first type, that is pattern recognition method. Pattern recognition method. Right? So you will be having questions like draw a DFA to accept the string consisting of like at least 1A, exactly 1A. Some pattern will be there in your question. So I'll write first question. Right? So that it will be easy for you to understand. So your question will be, draw a DFA to accept strings containing of at least 1A. Okay, so you'll be having questions like this, right? So first step is I have to identify, right, which type this question belongs to. I have three types: pattern recognition type, divisible by k and mod k problems, right? So by reading the question, I have to identify the type. So we are learning the first type, pattern recognition method. In pattern recognition method, when you read the question, a pattern will be there in the question. Right? So here you read the question, draw a DFA to accept strings containing at least 1A. So some pattern is given in the question. Right? So I can understand this question belongs to first type, pattern recognition method. Right? So I'll repeat once again. In pattern recognition method, a pattern will be present in your question. Right? So when a pattern is there in the question, you take and write the pattern as your minimum string. Right? Whatever pattern is given in the question, that is your minimum string. So here A is given. Right? So I am going to write my minimum string as A. Right? Then I have to write my alphabet. Right? So you can read the question. Apart from A, I don't have any other symbols in my question. So my alphabet is also A for this question. Right? Now I have to draw my transition diagram. Right? While drawing the transition diagram, what I have to do is like whatever string is given in the question, right, with that string I have to draw my transition diagram. So here in my question pattern is A. So using this pattern, draw your transition diagram. Right. So how to draw a transition diagram? Right. This is my state. Right. I have only one string in my minimum string. Only one element in my minimum string. So I'll write A. Right. So always represent the start state with start state. How it is represented is a state with an input arrow is your start state. Final state, it is represented with double circle. Right. Right. Now you have to name these states. While naming these states, you can start from Q0. That is, Q is the name you are giving and suffix you can give as Q0. So the next state, it will be Q1. You will follow this ordering: Q0, Q1, Q2, Q3. Right. So now there may be a question, why I am stopping with only two states. Right. Why I am stopping with only two states? In my minimum string, I have only one element. Right. So to mark this one element in my transition diagram, I need two states. Right. So it is starting from start state and it is ending in my final state. Right. Now I have to finish this transition diagram. So how to finish this transition diagram? Right. So for this answer, I have concluded I require only two states. Right. What are the states? Q0 and Q1. So now you can write Q0 of, right, Q0. This is delta. Delta represent transition. Right. First state is Q0. Q0. Right. Now what you have to do is like write your alphabet. Right. So my alphabet is A. Right. For the first state, I have written the transition. Now write the transition for a second state. Transition, second state name is Q1. What is my alphabet? A. Now I have to find out these two transitions. Right. How to find out these two transitions? By seeing this diagram, I have understood Q0 state. Right. This is an outgoing edge. Right. This is outgoing edge starting from Q0 and it is ending in Q1. So it is an outgoing edge. What is the meaning of outgoing edge? Q0 state, it is accepting the input A and it is moving to Q1. That is, when Q0 state accept A input, there is a transition to Q1. I repeat, when Q0 state accept A input, there is a transition to Q1. So Q0 state, when it accepts A input, there is a transition to Q1. Right, there is a transition to Q1. Now, next transition I have to find out. This diagram, it is incomplete. So with the minimum from the diagram, right, now this diagram I have to complete. I have to complete all the transitions. Right. So this diagram is incomplete. Now how to mark this transition? How to find out this transition? What is this telling? When Q1 state is accepting A input, right, where is the transition? I have to find out this transition. Right. So to find out this transition, right, first I have to mark self loop. If self loop is not possible, I have to move to previous states one by one. Right. If this 2 is not possible, right, I'll be moving to my dead state. I'll be moving to my dead state. Right. Now, I'll use a pencil. I'll mark first this self loop. What is self loop? State taking an input and staying in the same state. This is my self loop. Q1 state, it is taking A input and it is staying in Q1. Right. I'll tell once again. Q1 state, it is taking A input and it is staying in Q1. Right. Now I have to check whether this marking is right or wrong. Right? So what is my question? Draw a DFA to accept strings containing at least one A. Right? Now I have to check whether this marking is right or not. How to check whether this marking is right or not? I'll read the question. Draw a DFA to accept strings containing of at least one A. Right? So my string, it should have at least one A. So now I'll write all the strings. Starting from start state, write the string. Right? So I'll be having A. This is my string. Check the string. What is my condition? It should have at least one A. What is the meaning of at least one A? One or more. So I have at least one A. So this marking is right. Right? So here what will I write? Q1 comma A is nothing but Q1. Right? Now I have to finish my DFA. Right? You have to write the conclusion. Machine is equal to, you know what is DFA? It is a 5-tuple machine with Q, sigma, delta, Q0 and F. Right? What is Q? Right? The states in my DFA. How many states I have? Q0 and Q1. And what is sigma? My alphabet. Right? What is your alphabet here? Only A. Right? And transition, you have to write these two transitions. Right? And what is your Q0? Q0 is start state. Start state. And F is your final state. Which is your final state? Final state is Q1. Right? How will you identify final state? States with double circle is final state. Right? You have written your machine. Now you have to draw your transition table. This is transition diagram. Transition table. Transition table. Right? You mark this simple transition. And how many alphabets you have? Here you have only one alphabet. Alphabet you write in columns. And in row you have to write all the states. How many states I have? Q0 and Q1. Now you can check Q0, when it takes A input, it is moving to Q1. Q1, when it takes A input, it is moving to Q1. Q1, when it takes A input, it is moving to Q1. So here in the transition table, I'll represent my start state with arrow mark and final state with star. Right? So this is all about your question. Designing a DFA.